Hello, in today's class we are going to see the subject measurement and instrumentation. So the general objective of this subject is to understand the construction and working of D'Arsonval galvanometer. Next, the specific objective is, first one, we are going to recall the types of instruments. Second one, explain the construction and working of D'Arsonval galvanometer. Third one, going to illustrate the working of D'Arsonval galvanometer and derive the deflecting torque. So the measurement of any quantity plays an important role not only in science but also in all branches of engineering, medicine and in almost all human day-to-day activities. So the technology of measurement is the base for the advancement of all this measurement, which is responsible for the design of new equipments. So measurement of a given physical quantity gives an in-depth knowledge about the quantity which is to be measured. So for the measurement to be meaningful, we have to choose a proper instrument and a proper procedure is to be followed to measure that particular unknown quantity. Okay. So first we will see what is measurement. So measurement is the process by which we can measure the unknown quantity by comparing it with the standard one. So instrument which is used for this measurement is called as measuring instrument. So the instrument senses the physical parameters like pressure, velocity, temperature, etc. and process it and translate into a form which can be easily interpreted by the observer. And also the instrument must control the data which can be obtained, monitored and it can be delivered in the form what we want. Okay. Next we will see the classification of instruments. First one is analog and digital instrument. Second one is manual and automatic instruments. Third one, self-operated and power operated. Fourth one, deflection and null type. Fifth one, absolute and secondary instruments. Let's see the classification of instruments one by one, right? First one is analog instruments. So in analog instruments, the signals of the analog instrument varies in continuous fashion. The signals varies in continuous fashion and we can take an infinite number of values, can take infinite number of values in a given range. The example for this analog instrument is ammeter, voltmeter, speedometer of an automobile, etc. So, the analog instruments, the analog signals vary in a continuous fashion. I can take infinite number of values over a given range. The example is analog ammeter, voltmeter, speedometer of automobiles. Second one is digital instruments. Here the signals vary in discrete steps. We can take finite number of different values in a given range. So, instrument used is digital instrument. The example for digital instruments is multimeter, it is digital multimeter, odometer of an automobile, timer on a scoreboard, etc. So, analog instrument signals vary in a continuous fashion. In digital instruments, it vary in a discrete steps. So, in analog instrument, you can take infinite number of values in a given range. Digital instruments, we can take finite number of different values in a given range. Let us see the example for analog instrument. Here, this one is the analog ammeter, which is used for measuring the current. Okay. So, here the analog values, infinite number of values can be taken in a given range. Here the range is 0 to 25. So, we can take infinite number of values when supply is given to this. So, as example of analog instrument. Okay. Next one, digital instrument. Here it is a digital multimeter. So, the digital instrument, the values varies in discrete steps. So, we can take finite number of digital values. Example I am showing here is a multimeter. In multimeter, we can measure the voltage, current or power in discrete values. This is an example of digital instrument. Next one, we will see manual instrument. So, manual instruments needs the service of an operator. Example is measurement of temperature by resistance thermometer incorporating Wheatstone bridge circuit. So, the operator is required to indicate the values of temperature from this resistance thermometer. So, the service of an operator is necessary for manual instrument. Next one, self operated instruments does not require any outside power for its operation. The self-operated instruments does not require any outside power for its operation. Example is mercury in glass thermometer dial indicator, etc. Next one is automatic instruments. From the name itself we can say that automatic instrument does not require operator for its operation. So it can be automatically recorded. Next one is power operated instruments. So in power operated instruments, it requires external power for its operation. Okay. Example for this power operated instrument is electromechanical devices. Next one is deflection type instruments. So in deflection type instrument, the readings are indicated by the deflection of the moving system in that particular instrument. Example is ammeter, voltmeter, wattmeter, etc. So the reading will be indicated by the pointer, the help in the deflection type instruments. So here example ammeter, the ammeter needle will indicate the amount of current flowing through it, and the voltmeter will indicate the amount of voltage. Voltmeter will indicate the power. So the indicator or the moving element will be responsible for this showing the unknown quantity to be measured. Next one is null type instruments. A zero or null indication leads to the determination of magnitude of the measured quantity. Example is DC potentiometer. So null type instrument, a zero or null indication will be shown by the instrument in order to determine the magnitude of the measured quantity. Example for this null type instrument is DC potentiometer. Next we will see electrical instruments. Instruments used for all electrical measurements are called electrical instruments. So the three basic quantities in electrical measurement are one is voltage, current, and third one is power. So the instrument used for measuring these quantities, so for measuring voltage we will use voltmeter, for measuring current we can use ammeter, for measuring power we can use wattmeter, and also we can measure energy by using energy meter. So instrument used for measuring all these electrical quantities are called electrical instruments. These electrical instruments are broadly classified into, you see the classification of electrical instruments. First one is absolute instrument. So these instruments indicate the unknown quantity in terms of physical constants of the instrument. So the measured quantity is in terms of physical constants of the instrument. The example for this absolute instrument is tangent galvanometer. So in tangent galvanometer, the quantity will be measured in terms of tangent of deflection angle, the radius, and the number of turns of galvanometer. So here the deflection angle, radius, and number of turns of galvanometer are the physical constants of this tangent galvanometer. So the absolute instrument tangent galvanometer indicates the value in terms of this physical constants. So next classification is secondary instruments. So the value of measured quantity will be indicated by the deflection of the instrument. So by the deflection of the instrument, the unknown quantity can be measured. So for this process, the instrument has to be pre-calibrated, with absolute instruments. So the calibration is necessary for maintaining the accuracy of the reading. So this secondary instruments is further classified into three types. One is indicating instrument. What is indicating instruments? So these are instruments which indicate the instantaneous value of electrical quantity to be measured at the time at which it is measured. So indicating instruments are the instruments which indicate the instantaneous value of electrical quantity to be measured at the time at which it is measured. So the indication is given by the indicating instrument. The indication will be given by the pointer which moves over the calibrated scale, which measures the unknown quantity. So example of this indicating instrument is ammeter, voltmeter, wattmeter, etc. So already I have shown the indicating instrument. So this is an example of indicating instrument. This is an ammeter where the needle will indicate the value of current flowing through the circuits over a given range. You will get instantaneous value of current, right, at that particular time at which it is measured. So over this given range we can measure the instantaneous value. It's an example of instantaneous instrument. Second one is recording instrument. This instrument gives a continuous record of the quantity being measured over a period of time. So, over a period of time, continuously the readings will be measured and it will be recorded. So, in such recording instruments, the readings are recorded by drawing the graph. So, the readings are recorded by drawing the graph. So, the pointer of this instrument will be having a marker, the marker may be pen or pencil. It will move over a graph sheet. It will move over the graph sheet and the readings will be drawn on the graph sheet. So, example for recording instrument is XY plotter. Third one is integrating instrument. So, it measures total quantity of electricity delivered over a period of time. Example for this integrating instrument is energy meter. So, the total quantity of electricity delivered for a period of time will be measured by this integrating instrument. Example is our household energy meter. So, how this reading is measured is, it registers the number of revolutions made by the disc to give the total energy delivered with the help of counting mechanism. Yes, so far we have seen the classification of instruments. So, we have recalled what are all the types of instruments. So, first one is the analog and digital instruments. So, in analog instruments, the analog signals will be in continuous fashion and it can provide a finite number of values. Example of analog instrument we have seen is analog ammeter, voltmeter, wattmeter, etc. Second one is digital instruments. In digital instruments, the measured quantity will be in discrete steps and we can take finite number of values for a given range. Example is digital multimeter. Right. Next one is we have seen what is self-operated and what is power-operated machines. Self-operated instruments needs external power supply for their operation. Right. In power-operated instruments needs external power supply for their operation. Self-operated does not need any power. Next one is manual and automatic instruments. So, in manual instrument, we need external manpower for their operation in order to measure the unknown quantity. In automatic instruments, we does not need any manpower. Next, we have seen what are the types of electrical instruments. In electrical instruments, we have three types. Okay, one is indicating instruments. In indicating instrument, the unknown quantity will be indicated by the deflection of the moving system in that instrument. Example is ammeter, voltmeter, wattmeter. Second one is recording instruments. In recording instruments, the instrument will record the unknown quantity to be measured over a period of time. Example for recording instrument is XY plotter. And third one is integrating instrument. Integrating instrument which will indicate the amount of electricity delivered over a period of time. Example of integrating instrument is energy meter. So, we have three classification of electrical instruments, right? Indicating, recording and integrating instruments. Next, we will see the selection of instruments. So, the important factors to be considered for the proper selection of instruments is, first one is accuracy expected from the instrument. So, what range of accuracy is expected for that particular measurement is to be considered. Second one is when the final data is required. So, when the final data is required, that is at the time of, taking measurement, at the time or later. And third one is the cost. So, the cost of the measuring process. measuring process cost is to be considered while selecting the particular instrument for a particular operation. Next one is, in what form the data should be displayed. How the data should be displayed. We have seen whether it should be indicating or whether it should be recorded or integrating. In what form we need the data. Next one is whether the quantity to be measured has constant value or time variant. So, the quantity measured must be a constant value or time variant. Depending on that, we can choose the instruments. So, selection of instruments, accuracy, when the data is to be required, that is at the time of taking reading or later, the cost criterion, and the data should be displayed in what form, and the quantity to be measured is constant or time value. Quantity to be, the quantity to be measured is constant or time variant quantity. Right? Next we will see the essential requirements of a measuring instrument. So, the basic essential requirement of a measuring instrument is, while introducing into the circuit, for measurement, the instrument should not alter the circuit configurations. So, if you are introducing a measurement instrument into a circuit, the circuit conditions should not be altered. Second is, power consumption should be small. The power consumed by the instrument which is used for measuring should be small. These are the essential requirements of a measuring instrument.